Oh, I better turn that down. Ooh, my favorite student, good old Anne. Number 1 says this: a current of 2 amps flows through a resistor R1 as shown below. Gotcha. What's the current flowing through the 5 ohm resistor? Well, I thought maybe I can combine the... Oh, wait a minute. They told me how many volts are right there. How many volts are right there? So from here to here, how many volts do I lose? Say it again. So you're saying from here to here, how many volts do I lose? Say it again. So from here to here, how many volts do I lose? Also 8. You know what? If I put 8 volts right here, I know 2 things. In fact, I can find the current. It's going to be 8 divided by 5. Is it 1.6? Yeah. I didn't need to combine anything. I could use my skiing tricks, Kirchhoff's laws. Number 2, 3 identical light bulbs are placed in a circuit as shown. Which of the following is correct? The voltage, you know what? I think what I'm going to do is I'm going to make up some numbers and just crunch this. If I'm making up a battery, one of my go-to numbers is 48 volts. Why? Because lots of numbers go evenly into 48. In other words, don't pick 7 or 13 volts. Do yourself a favor. 20, 24 is also fine, but I'm going to make this 48 volts on the off chance that this will help things work out evenly. Who knows? And then it says they're identical bulbs, so they must all have the same resistance. Identical resistances. You know what? I'm going to go 10 ohms, 10 ohms, 10 ohms. Okay. Hey, how many volts go through Z? In my made-up example, 48. How many amps go through Z? I guess in my made-up example, 4.8 amps. So, how many volts from here to here? How many volts from here to here? Also 48. Now, it's not 48 plus 48. This is a 20 ohm resistor in series, and so I can go 48 divided by 20 ohms, and I can tell you how many amps are going up there. It's going to be, oh, I can do that in my head. 48 divided by 2 is 24. Up here, I have 2.4 amps. So I have 2.4 amps there, 2.4 amps there. Yeah, you know what? I have 24 volts, 24 volts. That makes sense. Since the resistors are identical, they should split the voltage. Now, I've got some numbers, and I'm going to just cross out and check mark answers that I like or dislike. The voltage and current, no. The current in light bulb Z is less than the current in light bulb X. Is 4.8 less than 2.4? Nope. The current in bulb Z is greater than the current in light bulb Y. I agree with that. I'm not going to circle it yet because maybe there's a better answer, or maybe I've made a sloppy reading mistake. The voltage across Z, 48, is less than the voltage across X, 20. No, it's bigger. It's gotta be C. Gotta be C. Okay. Is that all right? That's how I would handle it. By the way, you can do it intuitively. What you could have said is, oh, these two combined will have a bigger resistance than that. You could have combined them in parallel. You could have, but if you're, make up nice numbers if you're in doubt. Number 3, now we're solving. What's the total current leaving the battery? I'm going to start right there. Well, actually, first I'm going to label downhill, and then I'm going to start right there. Downhill is that way, that way, that way, that way, that way. Why am I going to start right here? I looked. I didn't see amps anywhere, but I always check that first. Then my next thing is, do I know 2 things? I know 2 things here, so I can tell you that the current is 8.5 divided by 60. 8.5 divided by 60. And I get that kind of a yucky number, but that's okay. I'm not even sure if I needed to find that current. I did kind of absent-mindedly, but maybe I didn't need to find it because how many volts on that branch? How many volts on this branch? Got to be 8.5 because they started and ended at the same spot. So, okay, this is going to be 8.5 volts. Oh, I can tell you the current here. It's going to be 8.5 divided by 40, 0.2125. This is 0.2125 amps. I think now I have the total current. I think the total current is going to be 0.2125 plus, you know what, I'm just going to go 8.5 divided by 60 rather than round off, and then I think that's the total current, 0.3541667. If you wrote 0.354 or 0.35, I'm good with that. But I think I total is, not 0.0, 0.354, 1 and then 6 repeating, which is 0.354 amps. I kept the longer number in case I need it. Cool. It's got to be a part B. Oh, what's the voltage of the battery? Well, I have 0.354 amps running through here, so this voltage is I times R. I have 0.354 amps running through here, so this voltage is I times R. Looks like it's going to be, I can do this one in my head, 35.4 volts, and this one up here is going to be times 25, 8.85, sorry, not 35.4, how about 3.54, Mr. Dewick? Apparently I can't multiply by 10 in my head. Shut up. Oh, was the mic on for that? Sorry. Mic is off. Shut up. There, mic is back on again. 3.54 volts. And what was it? 8.854. So I guess the total voltage is going to be 8.54. 8.854. Didn't even write it right, Mr. Dewick. Someone's in a bit of a slump here. 8.854 plus this middle one, I could use either of these 8.5s, plus 3.54. Total voltage is this plus 8.5 plus 3.54. Total voltage is 20.9. Now, if you got that, first of all, if you got A, 3 out of 3, if you got B, 4 out of 4. Otherwise, how would I give out part marks? For part A, I would give you 1 mark if I saw that you had realized that the 40 was 8.5 volts. I would give you 1 mark if I saw that you had noticed that that meant it was 0.2125 amps. I would probably give you a half mark for that, and then a half mark for the answer, something like that. For part B, for 4 marks, okay, I would give you definitely 1 mark if I saw that voltage, 1 mark if I saw that voltage. I would give you 1 mark if I saw that you had realized you needed to add those 3, and 1 mark for the answer. Find the power loss through the, okay, I'm going to find P here. You know what? I don't need to rewrite this. I can start there. Pretty sure I can get this without having to rewrite this circuit. Downhill, 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 downhill. The fact that we didn't need to rewrite any of these, I bet you on quiz 2, you're going to have to rewrite some of them by going 1 over R parallel plus 1 over is 1 over blah, 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 blah. Okay. Current is going to be 6 divided by 4.5. This might work out nice. 1.333333 amps. Oh, I also know that this is 6 volts. So 6 divided by 9 is 0.6666 plus 1.333333. You know what the total current is? I think exactly 2. Yeah. So this has a current of 1.333. No. 0.667 amps. And so I know leaving the battery is 2 amps. So I know I have 2 amps going through there. I have 2 amps going through there. Oh, I know 2 things. I know this is 32 volts. Actually, I'm kind of done. They wanted me to find the power loss through the 5 ohm resistor. One way to find power from my formula sheet is I squared R. I don't even need to find the voltage there. I can simply go I squared 2 squared times 5, which I could have done in my head. Is it 20? No, yes? 20 watts. So if you got that, 4 out of 4. Otherwise, I would give you 1 mark for that, 1 mark for that, 1 mark for that, and 1 mark for the answer. And in terms of showing work, clearly label stuff. If you type something in on your calculator, I really over here should have written 6 divided by 4.5 or done that down here somewhere. And I should have written 6 divided by 9 or done that down here somewhere. Try and show me it somewhere and I'll find it. What's B want me to find? Oh, suppose the 4 ohm resistor, the 4.5 ohm resistor, that one is removed from the circuit. If this is a light bulb, how does its brightness compare? You know what? I'm going to use this because its resistance isn't going to change. What will change is how much current is going to go through it. If this gets bigger, it's brighter. If this gets smaller, it's dimmer. What happens when I remove a resistor in parallel? What happens to R total? What happens when you add a resistor in parallel? What happens to R total? When you add a resistor in parallel, actually R total gets smaller when you add in parallel. So when you remove in parallel, R total increases. So you ready? I would say this. R total increases. And since I total is V total over R total, this just got bigger. What happens to this answer? What happens to the total current? I total decreases. So this is kind of weird. When you remove this light bulb gets what? Dimmer. Dimmer, it turns out. Therefore, 5 ohm bulb, Mr. Dewick, learn to spell, is dimmer. And if you actually crunch the numbers, you would find less power. So this one I did purely algebraically, but I would give you full credit, Naomi, if you just resolved the circuit and said, oh, it's not 20 watts, it's like 17.6 or something like that. It's a dimmer bulb. My mom says I'm a dim bulb. She means something different. 1 mark for circling that. And then if somewhere you mentioned a power equation, either V times I or I squared R, I would give you 1 mark because, oh, you've clued in what we're looking at. And then I'd be looking for a good argument here. Can you give yourself a lovely score, please, out of 16?